Hello everyone. I'd like to thank you to this talk by Circo today, focused on cloud computing, and this is part of the Science Week at the University of Lincoln, and this is one of the talks that is housed in the School of Computer Science. So first of all, I'd like to introduce you to Ben Johnson from Circo, and Ben is going to introduce some of his team who are also from Circo today, and we're going to run through a presentation on how cloud computing is applied at Circo, and then we'll be able to take questions and answers after that in the session. So on the YouTube stream that you'll be watching just now, you'll have the opportunity to post up any questions, and we'll answer them as we can go along if possible, or if not, we'll do that at the end of the presentation. So thank you. I'm going to hand you over to Ben Johnson, and I hope you enjoy the talk.
Thanks, Derek. Appreciate that. Thanks for the introduction. Thanks for the opportunity to come and talk to the university today. Really grateful for that, excited about it. So I've got a couple of colleagues with me today, and I might just need a little reminder from Kieran in terms of the slides. Are we able to, I can't quite see the slides on my screen, Kieran, Derek. I can see myself and not the slides. Wonderful, there we go. Thanks very much. Done like a professional. Thank you. So, right. So we're here to talk a little bit today about cloud computing. Actually, myself, colleague Alan Robertson, Andy Hart. If we want to click onto the next slide, we've got a glamorous mugshot of all of us. Some of that is true. The glamorous bit is not so true. So there we go. So we've got Ben, Alan, and Andy. We're also joined today by a special guest, the VIP of ours, Mike Appim. And Mike is actually a student at the university, and he's done some work for Circo. We had Mike on a year secondment last year, which was great actually. And Mike will talk a little bit about that later on. So thanks again for having us. This is going to be about 45-50 minutes. We'll try and get 10 minutes at the end for Q&A. So we're going to talk really about three things briefly. So a little bit about us, what we're going to talk about. We're just going to cover that again, enterprise cloud computing specifically, and how that works in the industry. You know, how we take the learning that the university is investing into its students, the extracurricular learning that you guys are doing, and how some of that translates to industry in real life, and indeed how there'll be some nuances there that people will discover as they go into real life with some of those skills to turn those into experiences. Okay, so we're going to cover a little bit about that. We're also going to talk a tiny bit about Circo, who we are, what IT opportunities we have to offer, and how that all relates to Science Week. So I'm just going to take you through, if we want to jump to the next slide, Alan, I'll take you through a little bit of background. So a lot of people often say we're the biggest small company you've never heard of. We're a FTSE 250 company. We are reasonably big in size. Big means 50,000 people spread across 20 geographies. Our UK headquarters, and that's our global headquarters, the UK, based in London. We are a public services business, so we do work for local and central governments all around the globe, and we are what is referred to classically as an outsourcer. So we take work that local government, central government do, and we find ways to make that more efficient through process optimization, and of course increasingly the use of technology, and that's how that fits into the Science Week. So Alan, Andy and I are from the technology part of the business, a growing part, and nearly everything we do in fact underpinned by technology innovation, and some of that technology cutting edge, and some of it more traditional, and Alan's going to talk to you a little bit about that. So we cover a number of sectors. We happen to work in the citizen services sector, you can see on the slide there, but the sectors we cover include defence, justice and immigration, transport, health. Some of you might have heard a lot about Circo in relation to health this year, some of it good, some of it less good, and I can assure you actually with regard to the less good piece, there's been unfortunately a bit of negative press around some of the track and tracing, test and tracing stuff. Not here to talk about that today specifically, but do feel free to look up on our website a lot of information about what we do and how we go about doing it. So if I want to click onto the next slide, I'm going to stop in just a couple of seconds. So big business, lots of values that we pride ourselves by. The innovation one is going to be the one that we zoom in on today, but because we work so closely with local and central governments, local governments in this instance, the example today being Lincolnshire County Council, where we have a base office. Because we work so closely, these values of trust, care and pride really important to us, because we are touching directly or indirectly the citizen, and so it's important that we upheld ourselves to those values. And if you want to jump to the next slide, we'll talk a little bit how that translates to Lincolnshire County Council, and then I'll pass off to Alan. So Circo's been working now with the council in Lincolnshire for about 5 years. So we are but a stone's throw away from the university, just the other side of the bridge. And there's a picture there, top right hand corner of our office, Thomas Parker House, where we've got about 300 or so members of staff doing a variety of things. And on the right hand side of the slide, you can see they range from IT, where we provide services for the council's infrastructure, some of which is hosted locally, so a number of local data centres that the council own that people might not know about. Hundreds of servers in those data centres that we look after. We look after the application support layer, including support and bespoke development and increasingly rapid application development, DevOps, as some of you may know it, and then more general technology, networks, telephony, mobile, what's referred to as end user compute, man in a van. So a whole range of services that we provide for 5,000 users that make up the council's user base. So it is the council end user base we're talking about, and also some citizen services in there for the 700,000-800,000 citizens that make up Lincolnshire. Above and beyond that, we provide contact centre services. So if you're ringing up to ask what day do you put out your wheelie bin, or how do you pay some sort of local tax bill, we will take that phone call, and we manage the telephony platform and the contact centre technology that goes with that, and also finance and payroll, getting people paid in the county on time, and payments to suppliers like social care workers. So what we're talking about there in science terms, in computer science terms, are ERP systems. So big enterprise resource planning systems like SAP, like Business World On. Some people will be familiar with Siebel. So big platforms, big databases, and consequently all the support skills that go with those. So last slide, I think, for me, just to finish the context. So you'll hear from Michael a little bit later on about how we believe we're contributing to the IT footprint that Lincoln increasingly is growing, and the university, of course, contributing greatly to that. We ourselves, our office is based above the Lincoln Digital Hub that was established last year, known as the Mosaic Centre. So there's quite a big technical footprint there at the Thomas Parker House building, and that's growing all the time. And one of the ways Circo grows that, and one of the things we're interested to hear from you guys about today and maybe after today, is our graduate recruitment programme. So we have a number of ways of pulling talent into the business, and the university producing a lot of talent, Michael being a good example, and we have 2 or 3 other examples of students we've taken from the university in recent years, and we've done great things with. So we have a graduate training program that's structured. Find out more about that on our website, and you'll see later on from Andy just a slide that tells you when the door is opening for people to come and register interest in that. Apprenticeships for people that want to take a more vocational route into the business, and also student placements, the sort of thing that Michael's done, the sort of thing that we've talked to Derek about in the past, and also the acting head of school, Salah, for computer science. So lots of opportunities at Circo, good place to be, growing business. Not here to pitch the organisation too much today. I'm going to hand over now to Alan, who's going to talk for about 30-35 minutes or so about cloud computing. and talk about the really interesting stuff, actually. So thanks, Alan.
Okay, thank you. Okay, so yeah, I'm going to just give kind of a high-level overview of things we've found in the last 5 years or so of as we've been migrating services for local authorities into first of all into private cloud systems, and then more recently into public cloud. And these are kind of the things that are not necessarily covered off in the traditional documentation. It's the things that you find as you're in the real world, as you're starting to try and do things, and the things that maybe catch you out sometimes or cause issues in other ways, as well as talking a bit about some of the benefits of moving into cloud computing and why organizations such as local authorities are looking at doing it. I mean, here's a set of logos of a handful of companies that really have embraced cloud, either through providing cloud services themselves or utilizing cloud services in order to provide their own. And that's just the first few that came to mind. There's many others. Cloud is the current thing that everybody's heading towards. So before I go on to talk about it, just a little bit about the how we've got to cloud computing being the thing. And in the beginning, there's a well-known quote that Thomas Watson, the chairman of IBM, said that he thinks there'll be a world market for about 5 computers. It's generally not believed that he ever said that now, but still, it's a good quote. Now, the key thing about that was that it was, well, you know, there's 2 computers in North America, a couple in Europe, and 1 for everywhere else. So it was a small handful of centralized, or the expectation was that would be a small handful of centralized computing services that were consumed by companies and to provide everything that they needed. Now, obviously, we know that that's not the reality. And the further away we get from that, the more ridiculous that statement seems. So in the beginning, we thought there was a few. Then we moved on to the point where it was, well, everybody needs a mainframe, you know, or a mini computer. Everyone needs their own big computer, which, you know, mainframes and minis are providing all the compute. You know, the dumb terminals on the front end, a big machine at the back end doing all the work. This photograph, incidentally, is actually from LCC. One of the members of staff on that photograph recently retired last year after working from the age of 18 for LCC. And this is one of the first big computers from the mid-80s. I think this photograph is early to mid-80s. When LCC were very proud of their new computer that went into their new data center. You can tell the age of the photograph by nothing else than the fact that there's windows on the data center. Data centers don't have windows anymore. They like to keep the computers and the people that work them in the dark these days. But it was the start of data centers, really. We needed data centers to house these computers. We need a whole set of infra to house these computers. And moving on from that, we got to the point where client server was the way to go. Again, we need big controlled data center, but instead of having one big massive machine in the data center, there was loads of little ones. This data center actually is CERN data center from, I'm not sure the date of the photograph, but judging by the fact that one of the labels that you probably can't quite see there says Windows 2000 servers, I'm guessing it's in the early 2000s. But the thing there was that we kind of realized, well, end user devices are getting quite good. People have got PCs, they're pretty good. Let's make the PCs do all the work. Servers do a lot less. Proper client server, you know, we put big thick applications on the end user machines and pull the data down and we'll do it. And that was the direction we kind of went. So, which is great. So you got lots and lots of Smaller servers, lots and lots of wires to join all those servers together. Most data centers, you go in and pull the floor up, it's a hell of a lot of cabling under there. And we need lots and lots of really smart people to make it all work and join it all up. And our end users' devices, as I say, had to become smarter, had to become more powerful, and were being utilized. Then we moved on from there and went, the internet. This is the way to go. You know, the American government developed a technology in the 1970s. Let's stick that everywhere. You know, American government's never seen us wrong. It'll be fine. So we sort of adopted a different model again. It became much more complicated with starting to send things over the internet. It's a lot more to it. It's a lot more things. So on the diagrams for it, well, let's just draw a cloud and we'll just some stuff in the middle, and hence cloud computing was born. You don't really need to know what's in there. You just need to know what goes in and what comes out, and that gives you the end effect. So there was a few kind of things we discovered with that, though, that the internet at the beginning was a bit slow and a bit rubbish. So we had to sort of re-centralize the workloads and make our servers do a lot of work again. And early browsers were quite thick and just basically displayed the output. So our servers started to become more important again and doing a bit more workload. So again, we expanded, kept with small servers, but more and more small servers, more and more things in the back end. We don't install a big application anymore. We just put a browser on and we zap it off. And that's kind of the way we went. And that allowed a lot of advancements that generally as a service became a thing. It's the new cloud. You know, we can now sell things as a service. People don't like buying a cloud because they don't really know what it is, but they'll buy stuff as a service. So, and there's a lot of different models and different ways to describe as a service. My favorite one is pizza as a service, and you can see the different way that you're chopping up that cloud provision. And the key thing about it is you're changing where the work is done and who does the work. The work still has to be done. You've still got servers that need to be looked after. You've still got applications that need to looked after. You've still got infrastructure that needs to be looked after. But the change is it's no longer by the customer. You don't have big amounts of infra you've got to take care of. You don't have to employ a lot of engineers to look after it. You don't need a big data center. You don't need a massive amount of aircon. The provider does all that for you, and you're just changing where that work happens. And there are some efficiencies that you get, efficiencies of scale and efficiencies of automation and things like that, which are easier to do on a larger scale. So now we're kind of in this situation where we've kind of come full circle on a lot of technologies. You know, Watson was kind of right in that it might have been wrong in that we only need 5 machines, but he was right in that actually we need someone else's machines, you know, that they can be provided by somebody else and you just consume it. And so even if the quote wasn't his, he ought to claim it because it was it's a good analogy of the way that things are now. And we can see that a lot of the technologies are quite circular in the way that the compute loads move around between end user and server. We're now moving back to things like HTML5 and things like that allow us to offload a lot of the work locally onto the end user devices again very easily, but without having to install a fat application on the end user device. We can do it. So we can see there's some pattern there. We can also see that we've got a rise in dumbish end user devices, things like Chromebooks and things like that. There's a rise in the utilization of those. So how does this kind of work in the enterprise? And our traditional model that we found a lot of customers have, and this is the way it works, is something like this, where you've got a data center, all your services are in your data center, you've got a load of sites, some of those might be physically adjacent to the data center. Some of them might be local access sites. So, for example, Lincolnshire County Council has a few hundred sites dotted across the county that all consume services from the data center. So that has moved on now, and the model that we're now approaching is something like this, which is hugely simplified. But a lot of these applications and email and things like that are no longer hosted in the data center. We've moved them off into the cloud. And some of those things are accessed still via the data center. You know, the data center is the route into that cloud, especially if it's a private cloud. Some of the others, you have local breakout and the ability to get over the internet and get straight into your mail servers that are in Office 365. You don't have to come back to the main data center to access that. So it's kind of changed. So that model, as I say, it's a hugely simplified version of it, but that's the way that a lot of things are going. And some of these little fluffy clouds might have, for example, be an Azure on an AWS virtual data center that has our services provided. But some of these are things like our software as a service. So we can now break out and we can get an application from the people that write that application. They will host it, they will manage it, they will provide it to us, and we just hook into it. So one of the key things about cloud is kind of to remember that it's just someone else's computer. As I kind of alluded to, you know, that work is still there. That work still exists. We're just changing who does it. It's still a server at the end of the day. It's still someone else's. There's nothing magic or mystical about cloud computing. It's just a data center full of servers, and they just present it to you in a new and interesting way. Okay, so benefits of cloud. Why would we want to go to cloud? Well, I'm not going to go into a massive amount of detail here. You know, there's an awful lot of people that will give you reams and reams of reasons for benefit. But all I'm going to do is just highlight the ones that generally cause these decisions to be made, and generally push people towards moving things into a cloud compute. So, for example, flexible. So, yeah, cloud is really flexible. You can do what you like. Well, yeah, it is. You know, you can make stuff when you need it. You can destroy it when you don't need it. And that can happen either manually, fire up a bunch of servers for you to test a concept or test an application or whatever you want to do, or it can be done automatically. So when users are hitting your machines hard, you can expand them and go, which is great. But that has a few kind of problems and a few things that you need to understand and need to be addressed. So how do you know when you want to make stuff? You know, what's your threshold? How busy does it have to be for it to automatically grow? And the other thing is, well, how do you make it smaller again? And in a lot of ways, how you make it smaller again is actually harder than making it bigger, because if you fire up 50 servers because your website is particularly busy or your application is particularly busy, you don't want 50 servers sat there when people have stopped using it and you've only got 5 users on each server, and all those servers are kind of mostly empty and they're still costing you an awful lot of money, but you've got a few users. So you need to kind of shuffle all those users down onto some of the servers, and some applications are happy with that. Some applications are not. Some applications are just the user comes in, they're on that server until they disconnect, and they stay there. And you have to find the middle ground between those things, because you can't have a server stood up to support a single user when you've got a whole load of others sat there. Someone's just posted a question about metrics dashboards or something similar, and yeah, you can. It depends on what it is. So it absolutely depends on what it is. Sometimes you will. And that's a key part of it, actually, that I'll talk about a little bit later on, is monitoring. It's working out, are you scaling things effectively? You know, if you are constantly running that all your servers are at 50% and you fire up another one when you get to 51, is that a sensible way of doing it? And reporting and monitoring is a key thing that you need to do for reasons we'll kind of talk about later on. Dynamic expansion, which we kind of talk about, is that it has some other interesting things that people that need to be thought about and catch people out. Because how do you budget for dynamic expansion? If you've got if when your web servers are quiet, you might only have 5. When your web servers are really busy, you have 50. Well, how do you know when you need 5 and when you need 50? Because throughout the year, that means that your bill for hosting that website or that application is going to go up and down continuously. You will have a change in your cost throughout the year. So how do you budget for that? Because the problem is accountants don't like things that they don't know what it is. So if the accountants really don't like it if you spend more money than you said you were going to do, but also they equally don't like it if you spend less money than you were going to do. So it causes some extra budgeting complications there about how you, at the end of the year, if your website wasn't very busy, is the accountant's going to cut your budget because you've not used it. And there is a story that a lot of offices leave their lights on overnight, not because there's people working or it's convenient, but because if they don't use all their electricity budget, it might get cut the next year. So they'll leave the lights on to use that budget up. And that generally is something that that cloud computing has caused changes of. The way we consume things directly produces a cost, and that cost needs to be budgeted, and that's not always as straightforward as it would first appear. Okay, so generally, costs for cloud, the finance aspects of it. Well, the key thing that everyone says is cloud is cheaper. Well, actually, straightforward running costs might be about the same. So to host a given number of servers on-prem, to host a given number of servers in the in a cloud, you might find over a year that there's not much in the cost, not as much as people think. Where the real savings come from is it's cheaper if you turn it off. If your server is not being used, if most of your users work 9 to 5 and you've got 10 servers, well, do you need those 10 servers running overnight, or can you get away with 1 in case someone decides to do overtime? So you can turn off 9. So overnight saves you running costs 9 servers. That tends to be where most of the cloud compute running costs savings come from things like that. Also, things like you can put offload from a traditional server based into a service. Azure and AWS, people like that offer services. So rather than having your own server running a SQL database, you can just use theirs as a service, and that can give you a saving, because especially if it's a relatively low number of transactions or low usage, might be a lot cheaper to do that than stand up some hardware to support it, or virtual hardware to support it. But we don't need to buy loads of new hardware, so that's a saving. Well, yeah, it is, but what if you've already got the hardware? A lot of data centers are sat there. If you've relatively recently refreshed the hardware, some people, their data centers are on regular refreshes, and the refresh every 5 years or whatever period it is. If you've only done that relatively recently, well, you've already paid that money out. Some people even sweat the hardware for as long as they possibly can. They'll keep that hardware going until they can it's no longer supported by the manufacturer, and it can no longer support the latest versions of operating systems or whatever it is. That again, well, that's a kind of a hidden cost that you're exposing by moving things into the cloud. That cost is not already there because you're utilizing it. Reserved instances, yeah, great. Reserved instances are cheaper. Yeah, you can upfront, you can buy a reserved instance. Brilliant. It's not a problem, but you need to be sure that you need it, because you're effectively buying that compute for the next 3 years, 5 years, whatever you're buying it for. I've literally been sat in meetings with people where they've said, right, we want to upgrade this system. But the way that we upgrade it is we have to build a new one. But the existing system, we've bought on a reserved instance, so we've got another 3 years to run on it. What can we do? How can we get around it? And there are ways to get around it, but it makes things a little bit more complicated. But again, reserved instance is a nice way to save a little bit of money. Okay. Next off, cloud computing. It's like a bridge. It's not a traditional analogy, I know, and it's not like any bridge. Actually, this is like a very particular bridge. This bridge is the Tamar Suspension Bridge, which goes between Devon and Cornwall. The key thing about this bridge is that it's free to get into Cornwall, but you have to pay to get out again. It has a one-way toll on it. And that's what makes it like a lot of cloud providers. A lot of cloud providers, data ingress into your cloud is free. You can upload as much data as you like. You just need to pay for the storage at the other end of it. But getting it out, well, we'll charge you the data transfer charges for that, and you have to pay to download that data again, which may be fine, because generally most people upload more data than they download, most enterprises. But there's a few things around that need to be thought about, and one of those is that often when you're actually moving the data between data centers or between subscriptions or between tenancies, there can actually be a data egress charge applies. So sometimes if your DR capability is, well, everything that gets uploaded into this database in Azure will replicate it and send it to AWS, for example, you can have a charge of every little bit of data you're sending out of Azure into AWS on your egress. You may well have a charge there, and again, that's a hidden cost that's not often thought about, not often included until it gets stumbled upon. So there's a lot that you need to do about DR and things like that. We'll talk about that a little bit, but you need to be aware of those kind of ongoing costs. So yeah, free to put your data in. You have to pay to get your data out. And incidentally, one of my colleagues apparently lives just behind us, and he says the bridge has now gone up to £2. Still quite a bit cheaper than getting your data out of Azure, though, I think. Okay, security in the cloud. I'm not going to go into it in too much detail. The great thing about public cloud is that all your internet, all your management interfaces into your cloud are all internet based, so you can get into them from absolutely anywhere. The problem with that is that they're available from absolutely anywhere, and anybody can get into them. People not many years ago, people would have shudder, and in fact they still do, about saying, oh well, we'll just publish our VMware vSphere interface onto the cloud. People can log on to it from wherever they want and manage it. You wouldn't do it, but that's exactly the way that Azure works. So it does mean that you have to think differently about the way that you deploy rights to your admins. And one of the things is that, for example, the credentials that are used to log into things like Azure or AWS are not the same credentials that they use to log into the domain admin on the local network. At first thought, you might think, oh, well, let's make them the same, it'll be fine. But that's generally not a good idea. There's a lot of things like that you can do, and there are some restrictions that you can put in place. There's some limitations you can put in place, but it's kind of a manageable problem, shall we say. The other thing that's quite interesting is that when people do want to gain access into your public cloud or private cloud, they may not want to do it for traditional reasons. It may not be that they're jumping in order to download all your data and get personal data. It might be that they want to steal some of your resources. It might be that they want to sit there with a Bitcoin miner sat in the background and do a bit of free Bitcoin mining. It might be that they want to run a some sort of malware control software that'll sit there trundling around the internet looking for zombie PCs. It may be that those kind of things are more interesting to them than your data. That your data might not be that good for them, but a set of free compute is invaluable. It's really useful to these bad actors. The other thing is that having everything in the cloud actually makes it easier to exfiltrate data. You can get it out, maybe a lot less noticed data coming out in the cloud rather than coming out from your local on-prem. So there's a bit of extra that needs to do there, and DLP, or data loss prevention, is a key part of that. Being able to set that up across your cloud offering in order to be able to scan for data exiting in ways that it shouldn't do is very useful. The other thing that's worth bearing in mind is that generally there's a lot less forensics available in cloud than there is on-prem. That is changing. There's much more forensics becoming available. It is going to improve as time goes on, but certainly it's worth bearing in mind. The other thing is the familiarity as well, is the engineers that look after your local infra will have a really good knowledge of exactly how everything works. In the cloud, that's not always going to be the case, so it's not always quite as obvious as to what's going on, partly because it's a lot more complex, there's a lot more capabilities out there. The other thing is shadow IT, when we're talking kind of vaguely about security. So shadow IT is basically any IT that is being used by end users that is not officially sanctioned by the IT department. And that has always been an issue, and it always will be. But recently it's become much more of an issue. It's much easier for people to do. They can now get themselves a payment card, set themselves up with an AWS or an Azure subscription, fire what they like up, and before you know it, they've got their own applications running, they've got their own systems running, all completely in the cloud, really easily. Don't have to worry about it. They may not have bothered with security, they may not have bothered with anything, and that's quite hard to detect, because all you're going to see is a URL in your proxy software as the users are going out and hitting that application that's now theirs. It's something that there are various techniques you can use to pick up, but it's something that is going to be more and more of a problem and more of an issue. And not only is the users setting up their own shadow IT and setting up their own AWS or whatever, but also they might just go and use a service online. Oh, I need to convert this PDF back into a Word file. What shall I do? Oh, there's a service that does it for me. I'll just upload the PDF to that website. Well, great. But where's that website live? It might be in China or wherever. What's the terms and conditions say? Oh, they're now on the content of that PDF file. Brilliant. And these kind of things are becoming much more prevalent, and again, there's a lot of work needs to be done in order to pick those up. The other thing is things like Office 365. Office 365 is great. It's really flexible, has an awful lot of capabilities. But if you run it out of the box, everyone can create their own SharePoint site. So before you know it, you've got a million SharePoint sites. Anyone can click on something in OneDrive and go, share this folder with anyone who has the link. Email that link to the world. So Dave's road trip mix can be shared with the entire world that can go and download it. These are all little bits and pieces that make life more interesting for an admin and need to be thought about in an implementation and picked up. Okay, skills. So cloud has meant that we need to change the way that we address our traditional skills model. It used to be, guys had come to people like Lincoln University, go get a qualification. Once they've got a qualification, they go out to industry. The guys in industry would go, do you know this technology? They'd go, no, I don't. Oh, okay, there you go. A week's course somewhere, come back with a nice shiny certificate that says, I can now install Novell NetWare. That is much less the model these days. These days, development needs to be continuous. It needs to be targeted, and there's some interesting kind of stats that get thrown around, or phrases that get thrown around, like the 70-20-10, which basically is saying, well, 10% of your learning you do on a course, 20% of your learning you get from somebody telling you about it, another colleague or something like that, and 70% of your learning you get from actually doing the job. And to be honest, that's not far away from the truth. That's what it often is that especially with things like Azure and AWS, their feature set, their modules, their capabilities change on a daily basis. Almost every day you can go on and there's a new thing appeared on the admin menu. What was that? So there's a and utilizing those new modules and new services is often a key to leveraging that platform and getting the best out of that platform. And it becomes a continuous cycle of people learning about the new technologies, deciding whether the new technologies can be utilized, and taking that through the whole development cycle of upgrade and iteration. Now, the problem with that is that often it means that you don't know how long it's going to take to implement it. Well, we've never done it before. It's a new thing, and we don't really know. We need to learn how to do it, and that needs to be in the cycle, and that can have an impact to your delivery. So things can take a bit longer to implement than they would with a stable technology that's understood. So that's where methodologies such as Agile or things like that come into benefit, where you've got the ability to replan, or you've got the ability to change your approach as you're going along, fail fast, throw in as many buzzwords as you want. It's those kind of things that we're moving on to. Okay, next off is governance, which I'm not going to talk about a real lot because it's not really all that interesting. But the key thing is that governance for cloud changes, just simple stuff like asset monitoring. Well, you've got a dynamic environment that you fire up a bunch of new servers when you need them and knock them down again afterwards. Well, what does that do to your asset inventory? How do you manage that? How do you ensure that those new servers that are being stood up have the latest set of patches of whatever on them, or the latest antivirus updates and things like that? How do you keep them in? How do you keep them monitored? What does that do for your software asset management? You know, if you've got an application and you're firing up and shutting down servers all the time, well, how does that manage anything to you know, how do you cope with it? Do you true up at the end of the year? Well, okay, that's great if you true up at the end of the year, but how do you know how many servers you used and if you had one and you turned it off? It's a bit more complicated. A lot of software vendors are now understanding cloud, and they're now making allowances for cloud, and they're now working in better ways. Some of them just don't have a clue. When you talk to some of the software vendors, they just, what do you mean you want to put it in a cloud? Well, it probably work, don't know. Okay. Monitoring, again, it's a similar thing. Monitoring is very, very important in a cloud environment. You need to monitor, you need to audit, you need to understand, for reasons such as we've talked about so far. Like, if somebody does hack into your cloud and create a Bitcoin miner, how are you going to work out which one of your machines is your Bitcoin miner, and who created it, where's it come from? You know, and how does that reconcile against your budget? You know, you've got an anomaly there, you need to work it out. Those kind of things. Real-time monitoring is are your servers up, are your servers down? Those are all different in a cloud environment. You need to find new ways to do it, which it's all doable. It's fun. It's part of the problem, and part of our job to make all this sort of stuff work. A couple of other things, getting towards the end now, there's a couple of other things that are worth just mentioning. This one has been in the news just recently, which is a little bit scary, which is OVH Cloud over in France, which caught fire over the last few days, and I believe is still down. That has kind of highlighted what I was going to talk about on this thing anyway, which is lost data. You put all your data in the cloud and you put it all in one data center, and something like this happens to that data center, what does that mean? And there's a lot of reports online of companies that don't know whether they're going to still exist next week because all their data lives in this data center that's on fire, and that's not a position you want to be in. Now, to be fair, a lot of this is a well-known thing, and a lot of the documentation will say don't rely on a single data center. Make sure you've got it in multiple availability zones, or whatever the term is for the technology you're using. But it does highlight that it is a very real, genuine problem. The other thing is that even though you're giving all this data to your cloud provider to look after, most of them won't take any responsibility for that data. It's up to you to make sure that you have that resilience there. They will give you certain techniques, such as I say, availability zones, failure domains, things like that, that allow you to protect yourself, but you do need to protect yourself because they won't do it for you. There's various other ways that you can lose data as well. Several years ago, people may be aware of geographic redundancy, exactly, of the Pirate Bay, which was a large torrent sharing site in Sweden, I believe, and they had an awful lot of stuff that they were sharing that the authorities decided they shouldn't be. So they raided the ISP that was providing their thing and took all the servers away. Unfortunately, a lot of the servers that took away were not actually Pirate Bay servers, and it took quite a while for people to get them back before they could do it. They could get their data back and get it running again, and that's a kind of a similar problem. It's those bizarre, unforeseen kind of things that can catch you out, and that you need to try and prepare for as best you can. The other thing is that not everything works in the cloud. It's simple as that. We talked about a bit about thick applications. You've got a thick application on a desktop, might not work over the internet, and the latency might just be too high. And the database connections tend to be the biggest culprit in this. Actually, is that trying to get back to talk to your Oracle database over the internet just may not be doable, and that end user application may just not work. And that's why you might still need to retain an element of local data center for these kind of applications. There's other things you can do as well, maybe remote desktop sessions, things like that, remote desktop services and things, in order to present that application in a different way. But sometimes that's just not feasible, and you need to find another way around it. The other thing to think about is vendor lock-in as well. If you start throwing stuff in Azure, utilizing Azure services, doing whatever you want, and then Azure push their prices up, it might not be that easy to move you over to AWS. So you kind of need to make sure that you understand what you're doing, how you're locking in, because if you get stuck in a single vendor, you might be there for quite a long while. And then lastly, migration. These are zebras, and apparently zebras migrate. I don't know, apparently this is what they say. So the key thing about migration is you need to plan, and then the next thing you need to do is plan, and then after that you will need to change your plan, and once you've changed your plan you can then implement, and the chances are it'll take longer than you think to do your implementation. Cloud will always throw extra things in that you didn't think of. A lot of those things I've talked about are things that have caught us out, or nearly caught us out in doing various different implementations and various different migrations and moving things across. There'll be a whole load of new and interesting things that you will find as you do it. So, in summary, really, cloud, is it a load of fluff? Well, probably not. It's quite good. We find there are an awful lot of benefits to putting stuff in the cloud, some of which I've talked about. There's an awful lot of things that can catch you out. There's an awful lot of things you need to change in your approach. The key thing, if you take sort of nothing else away from today, I would say the key thing is to make sure you're flexible, make sure that you can change your approach as need be, make sure you're willing to learn new things. I mean, somebody said, any advice for people who want to get into cloud? Anything you wish you'd known beforehand? The key thing that I would say is play with it, learn it, and play with it. The best way to understand cloud is by doing. Get yourself an Azure tenancy set up. Get yourself some free compute on it, and just build some stuff. Just see what happens. Set yourself a problem, go through the problem, build it, see if you can make it work, and then strip it down again before it costs you a fortune. Because it doesn't matter who you are, you will have. Everybody that deals with cloud will have had an unexpected cloud bill. It's one of the first rules of cloud computing. So that's kind of it from me. Before we move on, and there's no other questions in the comments, so I think it's Andrew's turn, who is going to talk to us a little bit about Andrew, Mr.
Very
Andy.
formal.
Yeah. Thank you very much, guys.
Yeah, thanks, Alan. Really good. So I'll just speak to you just a little bit more about the graduate program, a little bit more why Circo is a great place to work, and a few timescales, etc. for the graduate program. So initially, why Circo? As Ben alluded to at the beginning, it's meaningful. We've got vital services across not just the UK but the world. We, as you say, locally we look after the Lincolnshire County Council services, which Ben went through earlier. But we've got another couple of county and city councils across the UK that we help, and a number of services across there. We help the Australian Navy produce their ships. The same we just bought a company in America. We're helping with the military over there as well. So we're growing application. As it says, a world of opportunities. As I say, there's I've worked with Circo for 6 years, and there's a huge amount of opportunities, and I've grown myself into different areas, across Circo, and it's a great place, and the people are great. So, everyone's been extremely helpful. Everyone wants to help each other out, so it's a really good place to work. And we went through our values earlier with that Ben mentioned. And people do take it seriously, all the way straight to the top. Rupert Soames is the guy at the top for Circo, and he takes it very seriously that the values are. We all respect our values within Circo, so it's a great place to work. If you want to go to the next slide, Alan. It shows you just a few of the offices that are across the country that we've got. So you see there in Lincoln, we've got one, quite a lot down south near London. And what this slide's talking about is that it's a graduate program. You could, go to different areas within the UK if you so wish. So we've got a lot of places down south, Lincoln, a few northwest, and a few in Scotland around Glasgow. Next slide, Alan. So people we're actually looking for is obviously people that are generally interested in providing a really good service, have an open and creative mind, and want to try and progress. This graduate program isn't just for IT, information technology, but it's all different services. So if you don't, if you're not interested in IT, don't feel that this isn't for you. There are other services that we can put you in for. I can just see a flower now. So there's people that want to make a difference, people that want to challenge the culture. It's always good to have a fresh set of eyes come in and just challenge what we do. we do our job day in, day out. Sometimes it just needs someone with some new ideas come in and tell us, why you're doing it this way. And, sometimes it does trigger the mind to do things differently and better, smarter, quicker. So as Ben alluded to earlier, we have Mike Appin on the call. We not just do graduate programs, we also do, we have done locally some gap year placements. So we've done it for a couple of years now. Unfortunately, we didn't do one last year, but hopefully we'll be able to bring that back up in the very near future. So, Mike, I didn't know if you wanted to just spend a couple of minutes on kind of what you've done when you was with us for a year.
Yeah, kind of, yeah. So I'm Michael. Basically, I'm a current third-year student, and last year I got the chance to work with Circo in Lincoln. And I'll just tell you like a bit about like what I did day to day on a daily basis and like stuff like that. So first off, when I first started, I was given the chance to work with other departments, so I could shadow them and then kind of see what they do, and then spend half the day doing that, and then the other half I could like basically just take that time to myself and basically just learn new skills that I could use to help the business. Not only that, but also given the chance to like joining the online meetings. So this was like the morning prayers and evening prayers, where they basically just went over what was going on during the day, what they're planning to do, any incidents that happened, if anything went wrong, what it can do to make it better, and just like kind of talk about how the whole business is run. And this just gave me like a really good insight into like what Circo actually does and how they help LCC and the council do what they do. And it's also like a great opportunity because this is basically like a call with all the managers in it, so it just gives you a chance to like see what they have to do in that role, and kind of give you an idea of like what you have to like kind of plan to do in the future as well if you want to go for something like that. Apart from that, after a month of shadowing and learning, I was given a few tasks to do. One of these was making an overtime flow, which is basically a process that allows employees to kind of opt in for overtime. It sends an email to the managers to tell them about it. If it's over the limit, it can go kind of like to the next level above to like get them to approve it as well. And then basically when that's approved, the employee can go over and fill in the actuals, and kind of like it recalculates the cost that the pay that they'll get for that, and then basically displays it in different sources such as Excel and Power BI and SharePoint lists. And just apart from that, I also got the chance to like create apps using Power Apps, creating like a reception kiosk to allow people to come in and contact the department if they want to do. They want to like have a meeting or anything like that. Making a meeting booking apps to like book rooms. Resource management flow as well to like help with allocating resources to different projects. As well as like manipulate a load of data and like just kind of like just make everything run faster. Because the main reason why I was there was basically for automation. Sorry if I didn't go over that at the start. Just to make everything run faster and try and find like new ways to like trying to make sure like the whole business is a lot more smoother as well. During this as well, I also got the chance to have weekly meetings. So at the end of each week, I was given a lot of freedom to kind of like take my ideas and kind of like create what I wanted. But then I also had to like kind of display this at the end of the week just to to like a team of managers. And this was a bit scary at first, but after a while, you kind of just get used to it. And then you just basically kind of like go with it. So it's quite a friendly environment. So you don't. It's only scary at first, but once you get to know everyone, it's a lot easier to like kind of just fit in, if that makes sense. Apart from that, I got the chance to help out with incidents that happened. So that was like looking at tickets, calling customers, which obviously built my social skills, as well as just presenting my ideas and like what I've basically done throughout the whole time to like all the managers and employees over there. And not only that, but I also got the chance to create a SharePoint intranet site for the whole office, just to allow them to communicate better between each other. And one thing I'll probably say is that during the placement, I didn't really feel as if I was a placement student. I felt like more involved as part of like I was an employee there, because I was given the chance to like talk to like the managers and talk to each employee, kind of help them out and get them to help me out as well. And it just felt like quite a good place to like work and like just like an actual job instead of like me taking time off uni. And the last thing I'll probably add to it is that doing the placement as well, like even with Circo as well, it allowed me to like basically level up my skills that I could take into third year as well. So for example, I'm currently doing a DIS, and with that DIS, I can use Power BI, which I learned from Circo, to kind of look into the data and kind of like basically transform it and analyze it into like spreadsheets and dashboards that can show me what the actual data I'm collecting from my disk actually shows, and obviously give me a better mark as a result. And not only that, but I also managed to create an app for my athletic society using the skills I got from Circo, to kind of show what they can do and create like a leaderboard system for them to use during a lockdown. And yeah, just want to end it off there, just to talk about my experience and how great it was.
Yeah, thanks, Mike. Cheers, mate. £10 are in the post, saying how good we were. So yeah, it's on the way to you. No, thanks. And Mike was, we got him to do some, some of the things he said about our own intranet, and over time, so we still use today after he left. So it was a real good value members, and he did a lot for us, which was great. If we go on to the next slide, I think it tells you a bit about the timescales of the graduate program. So the people that are coming towards the end of their courses, life at university. So there's some applicants open in May, and on the next slide we'll tell you some useful links to tell you a bit more information about it and where to go. Ourselves here on the call, we don't actually deal with the graduate program or deal with the recruitment of the graduate program, but we're quite happy to help you out if anyone needs. So it's open up in May. There's an application form, some online assessments, and some virtual assessments to start in autumn this year. I believe last year, when we did this program, we had about 4,000 applicants, and that was whittled down to 20. So there's quite a few people that apply up and down the country. So thanks. So if you go to the next slide. Just a few useful links. As I say, by all means, contact either myself, Ben, or Alan. We've got some email addresses there. I think this slide deck will be shared. Is that right, Derek? Will this be shared with?
Yes. If you're happy with doing that, then yeah, we can certainly share it.
Yep, and there's a link there about the graduate program if you wanted to learn a little bit more, and we're obviously on all the social media sites, Facebook, LinkedIn, etc. Yeah, I think Ben, you just wanted to tail it off, but that's it from myself. Thank you very much for listening.
Yeah, thanks, Andy. Yeah. So the last thing, just before we hand back to Derek, then I suppose, so just to reiterate, our thanks for people giving us, and Derek inviting us to come and speak for an hour. Hopefully that's been helpful amongst the other things we've talked to Derek about in the past. We're very happy to do our little bit for the community, and the university is obviously a big part of that community now. So that means providing any mentoring or taking any questions offline, or if anyone wants to come and just taste a little bit of what it's like to do this thing for a day or two, whether that's a few days in the summer or during a term break or whatever. Totally open to that sort of thing. So feel free to reach out to myself. I look after the IT account here for Lincoln. Alan, who looks after our technical services piece, working with local teams in India, teams elsewhere throughout the UK, and Andy, who heads up our applications space across a number of our local government accounts, actually. So feel free to reach out, and we're happy to help in a number of areas. So hopefully that's been useful. We watched some of the talks yesterday and earlier in the week, some of the science talks, and all the stuff that Mike was talking about there. I guess the key thing to say is, but it all comes back to Alan's point, that was all done using cloud-based services, and it's very much the way the whole industry is moving now. So we'll hand back to Derek. Thanks for listening.
Thank you. That was great. Thanks for that, Ben and team. That was a great presentation, Alan, too. I really enjoyed it, and it certainly validates what we're teaching in terms of cloud at Lincoln, and the types of issues that you're going to face. So yeah, it's not as straightforward as you might think, as you pointed out several times for sure. And so we have developed a brand new MSc Cloud program at Lincoln, which will be launching later next academic year from October. And yeah, we'll be looking at polycloud, essentially, where there'll be Microsoft Azure, there'll be Google Cloud Platform, and then eventually AWS. But we're already delivering cloud courses at the university on infrastructure as code, for example, designing infrastructure, which is really difficult. And then the students actually writing the deployment code to deploy networks, mainly IaaS type services. And we're also looking at the Azure stack too, around serverless. And we've run modules on Internet of Things, for example, where we've used Azure IoT hubs, event hubs, serverless side of things, web apps, that type of stuff. So I'm hoping our students that are graduating now and in the future are certainly going to be meeting your skills needs at Circo. And I'm really keen for our students to apply to your graduate program too. So I'll be nudging that along in the right direction for you too.
Yeah, that'll be really good. Sounds really exciting.
So this video will be made available for our students that couldn't make it today. Lots of them do have scheduled teaching, so because this is an asynchronous call, they'll be able to get access to that via YouTube. So I'll just close off now with a big thank you to everyone at Circo for delivering this talk. It was very informative, very interesting, and really does help validate our approaches of teaching cloud at Lincoln. And I hope to meet you all again soon at some point and potentially run some more talks.
Yep. Thank you very much.
Cheers.
Take care then.
Thank you.